Next, we're moving on to the fourth lesson within this unit. It's called Exploring Improper Fractions and Mixed Numbers. We're continuing to work on this outcome where students are interpreting improper fractions. And so while we're going to continue to build on the skills and procedures that we've already been working on in this unit by modeling, and we're going to continue to express improper fractions and mixed numbers symbolically, we're also going to add on this one where we're going to express a number both as an improper and mixed number and be able to go back and forth between the two representations. So, we also really want to build in this understanding that improper and mixed numbers represent the same number on the number line. So that idea of equality and that they are the exact same thing, just two different ways of representing the same fraction greater than 1. This lesson starts by introducing a game that the kids are eventually going to play in partners, but we'll start off by playing all together as a class. So we'll put a big number line up on the board, and this number line is going to go from 0 to 3. And as a class, we want to partition this number line into thirds. So we're going to start by partitioning 3 into thirds. So I'm going to try and cut this into thirds. So this is going to be 1, 2, and 3. And then within these thirds, we want to cut each whole into thirds as well. We don't have to label these. Okay, so that's setting up our game, but it's nice to do that as a class because maybe you could intentionally make it a little wrong and have the kids correct you. Whatever you want to do to model this as you make this number line together. Now you'll want 2 volunteers to come up to play the game together. You're going to guide them. They'll play together as the class watches and supports them. So I'll have player 1 is orange and player 2 is purple. Now Mathology has the students choose the fraction they want to count by. You can also use manipulatives. Schools have these dice. They're 0 to 3 dice that the students can use. These are like the lowest denomination that we have. There's also 0 to 5 dice or standard 6-sided dice. I think the 6 is a little bit too much. I like the idea of 0 to 3 because each of these is going to represent a 1 unit fraction, 2 or 3 unit fractions. You can also use virtual dice if you just Google 3-sided, 4-sided dice even with a 0, or a spinner would work too, whatever sort of number generation tool you want to use, but I feel like going up to 3 is sort of ideal. So orange, player number 1, player orange is going to roll, and they get 3. So they're going to count up by 3 1/3. So as a class, let's watch player 1 represent their thinking by jumps on the number line, and we're all going to count together. So we start at 0, and we have 1 1/3, 2 1/3, 3 1/3. Now where the student stopped, we're going to write 3 thirds. That is our improper fraction, and this also represents 1 whole as a mixed fraction. Now player 2, purple, is going to take over. They can choose another number or they can roll the dice. Ooh, they also got 3. Look at that. So all together, they're going to continue off from where player 1 left. I should say too, the winner of the game is the first one to get to 3. I'm going to go 1 1/3, 2 1/3, 3 1/3. That's going to get us as a improper fraction 6 thirds or 2. Okay, orange. Ooh, 1 1/3. So we're going to count up 1 1/3. This is going to get us 7 thirds or 2 1/3 as a mixed number. Now you could co-create the rules here. For example, if I roll too much, then I don't get to go. Like I have to roll either less or exactly what I need to win, or whatever you want to do. I'm going to play that rule. 2, hey, player purple got it. 1 1/3, 2 1/3. So this is going to give us 9 thirds or 3. And because I got right there at the end, purple is the winner. The point of this is to be able to count by thirds, continuing to review that skill from the very beginning, but also represent numbers using the linear model and represent both mixed and improper fractions on the number line, identifying that they live in the same place. They are equivalent ways of representing the fraction. The next part of this lesson involves us showing this image to our class. This image comes from Mathology. We want to ask them as a whole class, what do you notice? And so some of the things that we want our students to notice is that there are 3 squares on the page, on the screen, and they are all the same size and the same shape. We also want them to notice that 2 of the squares are colored in solid blue, and 1 of the squares is partially covered solid blue. Now the 2 squares fully covered are not partitioned. They're not broken up into any pieces. They're just 2 solid squares. The third shape is broken up into quarters, and 3 out of those 4 quarters are colored in blue. And so what we'll do here is show students explicitly that we can represent this as a whole and another whole, and then each of these pieces are 1/4. So 1 1/4, 2 1/4, and 3 1/4. And we can represent this as 2 3/4, 2 wholes and 3/4 of the third whole. This fraction is called a mixed number, or this way of representing fractions. So it's a mixed number because we're mixing wholes and fractions together to get 2 wholes and 3/4 of the other whole. Talk about that for a little while. Then we can show this image, also from Mathology. We want students to notice that it's the same. So we say, what do you notice? And they'll say, well, it's the same. Three squares, all the same size and shape. 2 of them are colored in, 1 of them is partially colored in. But now the 2 that are fully colored in are broken up into quarters. That's the only difference. Everything else about this number is exactly the same. And that's exactly it. We're not going to call them wholes anymore because they're broken up. We're going to count them as unit fractions. So we have 1 1/4, 2 1/4, 3 1/4, 4 1/4, 5, oops, it's hard to do this, 5 1/4, and so on. And each of these sections, each of these pieces represent a quarter of the whole. And so then the question is, well, how many 1/4 do we have all together? And if we were to count them all, we're going to have 11 quarters. So we're not thinking about wholes here, we're thinking about unit fractions. How many 1/4 are there? There's 11 1/4. This is called an improper fraction. And so we want students to see in the end that mixed fractions, mixed numbers, and improper fractions are the same. They're 2 ways of representing the same number. One of them uses wholes, the other uses unit fractions. We could even go farther if we wanted to. You don't have to do this, but could we plot both of these on a number line? Our number line is going to start at 0 and ask the students, what does it have to go up to? I would say 3. And so we have to partition our number line into thirds, just like we had done before. And what do we partition each third into? We have to partition them into quarters, right? Because each of the 3 pieces is broken up into quarters. Now, to represent this on a linear model like we see here, our blue squares are area models. This is a linear model. To the mixed number, 2 3/4, we could say it's 1 whole, 2 wholes, and then 3/4 of the third whole, and that would end up right here as 2 3/4. Now, as an improper fraction, we're looking at unit fractions. So to represent this, we can say 1/4, 2, 3, 4/4, 5, 6, 7, 8/4, 9/4, 10/4, 11/4, and it ends up right here. And so we want students to recognize that both of these numbers end up on the same point in the number line. Though our number line, our linear model looks slightly different for each, they represent the same thing. They are equivalent ways of representing the same number. Now it's time to play a game. So this game is from Mathology. There's a slide that goes with it, as well as a printable that you can give to each pair of students. It's called Filling 3, and there's also a Filling 4 option if students want to play that when they're done. This game is played with 2 players, but you can also partner players up. So you can have 2 players as player A and 2 players as player B if students need to work together. On the board, you have the instructions, as well as on our sheet. You can give kids a bigger number line if that's what they need. And we have 3 game boards, so we can play this game 3 times. So game board 1 we'll start with here, and you'll notice that it's a number line from 0 to 3, and each whole is broken up into fifths. So we're working with fifths. Make sure students know what they're working with before we get started. So we have 2 players here, player purple and player blue. And so you can use the dice if you want. I'm just going to just going to play. So player one, I'm going to start with, you can either do 1, 2, or 3 fifths. So I'm going to start at 0 and I'm going to do 1/5, 2/5, 3/5. I'm going to stop there. When we stop, we have to record our number. So this is 3/5, and that's a mixed number at the top, and it's also the same as the improper on the bottom, 3/5. Okay, player two purple. Player two is going to do 3/5 again. 1/5, 2/5, 3/5, and that's going to give us 6/5 as a improper fraction and 1 and 1/5 as a mixed fraction. Player two is maybe going to do 1/5, 2/5, and we'll stop there. That's going to give us 8/5 at the top, and 1 and 3/5 as a mixed number. Player purple, we want to be the first player to get 3. 1/5, 2/5, 3/5. This is going to be 10, is this 11 fifths? 8, 9, 10, 11 fifths as a improper fraction. As a mixed fraction, we're at 2 and 1/5. And then blue is going to go, blue can't win. Well, yeah, it's impossible. 1, 2, 3/5. That's going to get us 11, 12, 13, 14 fifths. Or as a mixed fraction, 2 and 4/5. And then, of course, per player purple is going to win this one. This is 15 fifths, or 3 altogether. So you want to be the student that hits that 3 at the end. There's a little bit of strategy in there. Then they can play it 2 more times if they want. They can also play this game with relational rods or Cuisenaire rods, either physical ones or ones in the digital form. So the yellow is fifths. The yellow is or represents one whole, and the whites are a fifth of the one whole, so we just want to prove that. There's 5 whites that make a yellow, so we need 3 of them. This is kind of like it's a bit of a linear model, kind of an area model too, though. So there's our 3 wholes, and so player 1, I'm going to put 3/5, and of course on a whiteboard I would want to represent this. Player 2 is going to put 3/5, and we're going to represent this just the same way. And so they continue to go back and forth by adding their numbers, and whoever gets to 3 first is the winner. It's just another way of representing the game, the exact same game, different model. It's just going to help kids to grow their brains. When they're done, they can go turn it over and they can play filling 4. And now you'll notice down here, there's again 3 versions of this, but they can play 3 times. But now we go to 4, and each whole is split into quarters. So we're counting by 1 quarter, 2 quarters, 3 quarters, and representing it as a mixed and improper fraction each time. And the first player to reach 4 is the winner. So there's 6 game boards on here, 2 different ways of playing, and they can also play with alternate representations or make their own game board if they're done. So spend for sure a class and maybe even come back to it and do another class on this, or play filling 3 first and filling 4 on the next day, whatever you need to do to get kids counting and representing numbers on number lines as mixed and improper fractions. So let's take some time to consolidate some of this learning for our students. This is one of the images that's on Mathology, and we want them to notice that there are muffins in tins. We have 2 tins with 6 muffins in each, but 1 tin is missing 2 muffins. One is whole and then the other is missing 2. So how can we represent this as in 2 different ways? Well, we can represent it when we think about the number of wholes. There's 1 whole tin of muffins, and then the rest is there's 4 out of 6 possible muffins left over. So when we think about mixed numbers, we're thinking about the number of wholes there are. There's 1 whole and then 4/6 of whatever is left. So mixed numbers are very much focused on the whole, representing how many wholes there are. We could also represent this as an improper fraction where we're focused on the unit fractions, or the fraction where the numerator is a 1. And so each of these represents 1/6, right? And so on. So how many 1/6 are there? We don't look at the whole. We're simply counting unit fractions. We have 1/16, 2/16, 3, 4, 5, 6, 7, 8, 9, 10/1/6. And so we're focused on counting unit fractions here. This is called an improper fraction. So make sure that students have really solidified this understanding. We also want them to understand that these represent the same thing. You can draw these on a number line if you want to prove that again here, but we really want them to understand that equivalence, that it's the same way of representing the number, just focused on different things. Now, when we're converting a number from a mixed to an improper fraction and vice versa, we want to avoid an algorithm here. There isn't a requirement for them to do fancy like math tricks and stuff to be able to do this work. We want to build a conceptual understanding of this before introducing algorithms. So I wouldn't even introduce it at this point. What we want them to see is that if we can recognize that there are, for example, 1 4/6 muffins here, if we want to represent that as an improper fraction, then we're going to figure out how many 1/6 there are. Well, in this 1, how many sixths are in 1, right? If we look at the picture, there's 6 1/6 within 1. So that's going to represent 6. And then it's kind of like a counting on strategy, right? This 1 represents 6 1/6. It's the same thing as 6 1/6. So actually, let's even write it like this: 6 1/6. And then we're also going to add on 4 1/6. And we're going to add these together, like we don't even have to put a plus sign there, but we have 1 whole 6 1/6 and then 4 1/6. And when we put all the 1/6 together, we're going to have 10/6. And if you look at that, it's the same representation. So I wouldn't introduce an algorithm here, actually draw the picture out and have kids conceptually understand how to convert. Now, if we're going to go the other way from an improper fraction to a mixed number, so 10/6, let's do this here, 10/6, and we want this to be a mixed number, then we want to think about it as how many 1/6 there are and how many 1/6 make up a whole. Well, that's easy to figure out because our whole is divided into sixths. So out of that 10, 6 of them are going to be going to make up the whole. So we definitely have one whole. Do we have two wholes? Like, do we have how many 6 are going to be in 2 wholes? Well, that would be 12, right? So we don't have enough. So we definitely have one whole. And then how many are left over? Well, one whole is going to be 6 out of that 10. So then we need 7, 8, 9, 10. Is that 4 more? 4 more left over out of the 6. And that is exactly what's represented here, right? We have a whole with 6 muffins. And then, so that represents the one whole. And then we just continue to count on 6, 7, 8, 9, 10. That's 4 more out of the whole. That's 4, 6. Again, no algorithm. I wouldn't introduce division or multiplication, any of that. We really want students to understand how to do this conceptually using models before we introduce any sort of algorithms. If they can understand how to do this authentically using a model, using reasoning and justifying, then they will figure out that algorithm so much easier when we introduce that to them. So do some work as a whole class together on this. Here's another example of this this kind of work. It's the one that's in Mathology. They introduce the number 11/5. And so we want to ask the students, is this mixed or improper? We want them to say that this is improper because the numerator is greater than the denominator. So how do we convert this into a mixed number? Well, we want to figure out how many are in the whole. And our denominator gives us that clue, right? There's 5 in the whole. So if I have, say, a chocolate bar that's split into fifths, this is one way to represent it. There's lots of ways. How many wholes do I have with 11? Well, if I count these out, right, I have, let's highlight here, 1/5, 2/5, 3/5, 4/5, 5/5. So I'm up to 5/5. That's one whole. Can I keep going? Can I make another whole? I think so, right? What's another 5/5? Is that going to get me 6, 7, 8, 9, 10? Yeah, that's another. So that's like 10/5 here. That's 2 wholes. I have 11. So 5 and 5, that that's possible within 11. I'm up to 10. And then on my next one, fifths again. So I'm up to 10. I just need one more. So that gets me my 11 fifths. So that's just an extra 1/5, right? So we have 5 and 5 is 10. That's going to give us 2 wholes plus another fifth. As a mixed number, this is going to be 2 and 1/5. So when we draw it out in some model that makes sense to us, it's much easier to conceptualize it than it is to do multiplication and division and all of that. So give kids some some improper fractions, turn them into mixed numbers, give them some mixed numbers, turn them into improper fractions all together as a class so you can guide it and have kids talking about it and thinking about it, justifying their thinking and learning from each other. The printable practice pages built within Mathology include lots of really good leveled questions that we can give to students strategically throughout this learning. There's 5 pages here, so I wouldn't print these out and give kids this as a booklet to work on independently. I think we can be a little bit more strategic than that. So what I would personally do is give them 1 or 2 problems as maybe an exit ticket after a particular lesson, or cut them all up and identify mild, medium, spicy, for example, and let the students choose. So for example, this one here focuses on knowledge and understanding and also application. So they have to take these pictures and represent them as both an improper and mixed. I would say this is a mild question. Use a model to show these and draw a picture to show what you did. Mild, I would say as well. Here we're converting mixed to improper. Maybe these are medium, depending on where your kids are at, medium questions. Which of these improper fractions are between 3 and 4? How do you know? I would call this a medium. Mild, medium, spicy, this would be a medium. This one is about, do you agree? This is a communication question. I would call this a medium as well. Shade the picture. This is a mild. And then this one here, question 8 and 9 and 10, same thing. It just kind of continues to go on. I would give these kind of mild or medium. This one here, number 10, is a spicy. And then our exit ticket, I would do this one at the very end of the learning to determine if you're ready to move on to the next part of this unit. So if most of your students are able to do this work, because here's the strategy of choice, do they understand what we've learned? If they don't, we need to go back and continue to practice. If they do, we can move on to the next part. So this is our final assessment piece before we move on. And then back to our assessment rubric here. So where are your students in this progression? Slot their names in. We really want the goal to be for them to be able to compare and order fractions as mixed and improper, using benchmarks and being able to have that flexible thinking where, this number is a little more than 1, this is, closer to 2, ordering these numbers from greatest to least. So identify where students are at in this progression. This unit is sort of builds on these skills, less linear, but sort of blends them all together. So this assessment so far will tell us where our kids are at. If your kids are able to do this, most of your class fairly well, then it's time to move on.